Okay, hi everybody. Thanks for coming for the talk. I'm Mike Kolesnik. I'm a senior software engineer at Red Hat and a core maintainer in the oVirt's project. This is René Koch. You can introduce yourself.
Hi, I'm René. I work as a senior solution architect for List Linux Land.
Okay, and we're going to talk about expanding oVirt's horizons. So who here knows about oVirt? Oh, great. So it will be a really short introduction for it. Basically, if you have any questions, I'll be happy if you save them to the end because we are short on time. So, yeah. So let's look at what we're going to talk about. So first of all, small oVirt introduction for those of you who don't know what is oVirt. And then we're going to talk about two parts. First part is how to consume oVirt, which is just getting information and acting upon oVirt. This is important because it's going to be used in the second one, which is how to extend oVirt. We have VDSM hooks and the scheduling API and the UI plugins, which will be presented by René. So let's begin. So what is oVirt? I guess most of you already heard about it. Large-scale centralized virtualization. It is basically like an open source vSphere or vCenter. It's based on KVM. It gives us KVM and Linux, gives us great performance and stability and other features. And there are a great lot of companies behind it and also individual contributors which all create oVirt. So basically it looks like this. We have the web admin and the main tab is the VMs tab. We also have data centers, clusters, hosts, which all comprise the physical hardware. And then we have like a network, storage, all the resources and the VMs that we manage. It's really a feature-full application. You should check it out on ovirt.org. So first part, how to consume all this wonderfulness. So we have APIs. Basically, we have REST API, SDK, and shell. So basically, what can I do with these APIs? I can configure my infrastructure like host configuration and installation, configure networking on the host, configure storage resources. And I can do virtual machine configurations. So basically, networking on the virtual machine, storage, and setting up different devices, setting up memory, etc. Also, VM lifecycle management. Also, I can manage users. We have a very powerful permission system in place. And basically, all the operations in the UI and more, because some features are not exposed in the UI, only via the API. And the different ways to access the API. So we have REST API is just doing calls on URLs and getting a response. SDK, which is basically Python or Java SDK, just accessing it programmatically, and you get a list of objects that you can act upon. And in the shell, you can just do shell commands and get a formatted text result. So we'll be talking about the API concept. So basically, all APIs go through the oVirt engine, which is the main component, which controls everything. And all the APIs are built in layers. So REST API is at the bottom. Then on top of it, we have the SDKs. And basically, a shell is on top of the Python SDK. And we try to maintain backward compatibility so that if you have scripts or some programs working with the SDK or shell or the API, they wouldn't stop working when you upgrade to the next version. And we also have secure access, but because the security has to take place each time, each call, we also have session-based access, so you can get a ticket and reuse that ticket for each call. So let's talk about the REST API. This is the most basic, the core API that oVirt engine exposes. So basically, it's just doing HTTP methods, HTTP calls. So we have get to get a list of resources or a single resource representation. Post is to submit a new resource or to act upon an existing one, like launch a VM via post. Put is to update a resource or just update the representation. And delete, of course, deleting the resource. And the various media types we support, we have XML, and we have JavaScript object notation, JSON. Basically, it's mostly the same, looks like the same fields, identical fields, and you just choose whatever you want. You specify in the request which media type you send, and in the response, which response you want to get. It's up to you. So let's look at an example how we do things with the collections. To list all the VM resources, we just call get on the URL /API/VMs. To create a VM resource, we use post, HTTP post, on the same URL, and we need to specify in the body the VM that we want to create. And to act upon a single resource, so use get on the single resource. It's the same URL, VM/ the ID of the resource at the end. To update it, we do a put on the same URL with the ID, and we have patch mechanism, so you don't have to send the entire resource each time. You just send which fields you want to update. And to remove a resource, of course, just call HTTP delete on this URL. And basically, you can browse the REST API by yourself and follow the links and discover all the collections. But we also have RSDL to describe which actions you can take, what are the parameters that you can send to the API. So basically, it's always available on API !RSDL. And it's very easy to consume, especially for scripts. It's just standardized XML structure that describes the API and how to use it. So that's it about REST API. Let's talk about SDK that is built on top of it. And REST API is nice, but usually you want to access it more programmatically if you're extending oVirt. So basically, it's used more for integration, automation, and some advanced usages. And it's object-oriented, so you just access and use the objects. And current bindings we have is Java and Python stable ones. And we have also libg oVirt and rb oVirt, which are less stable. And some more are planned to be supported. And what are the concepts of the SDK? So basically, complete abstraction. You don't need to know which protocol is used. You just use the SDK like you would use any other library. You don't care that it's REST behind the scenes. And it's also fully compliant with the oVirt Engine API. So basically, every method that you can do, everything that you can do through REST API, you should be able to do via the SDK. And it's really self-descriptive, it's descriptive, it's really easy to use. Auto-generated, of course, all the SDKs are always kept up to date because they're auto-generated. And if you have the supporting environment, you also get nice auto-completion. So like in this example, we look at Python SDK. So I just import the API object in Python. And then I can create a proxy for the API. So I just give a URL, username, password, get a proxy object. And on that proxy object, I can list all the available collections or actions. So in this case, I can call VMs. And on VMs, I can see all the actions like add a new VM. So basically, how to add a new VM is just a few more steps. So again, we import the API and create a proxy for it. But we also need to specify a cluster and a template to create a VM. So we get the cluster, we get the template, and we create a parameter of the VM that we want to create. So basically name, cluster, template, and the amount of memory. We send it to the API VMs collection. We call add, and we get back the VM object that we can further act upon, like start this VM or add disks, add network resources, other kinds of devices. So that's it about consuming oVirt. Basically, there are lots of other things we can look about, but these are the basic concepts. And let's talk about how we can use them when extending oVirt, because that's what we're here to talk about. So starting with VDSM hooks. So to understand what is VDSM hooks, we need to understand what is VDSM. It's basically a component that runs on single hypervisor and manages that hypervisor, just manages the host and the VMs running on the host. And the hooks is just a mechanism that you can use to put scripts on that host, on that specific one host, and they alter the way that VDSM is running the VMs, and basically the operation of VDSM, like the daemon that is managing the hypervisor. So hooks are just called on specific lifecycle events. We will see like the full list. And they can sometimes modify the XML structure that is sent to libvirt, because VDSM, as we can see, is using libvirt to actually run the VMs. So it basically can do everything that libvirt supports. And also hooks can run system commands. So if you want to, say, apply firewall rules before you run the VM, you can do that. You just call IP tables, whatever. And you have more information. So the first link is just a general description of the hooks, how to write, how to use. And the second one is actually a hooks catalog, all the existing hooks that are available for use that you can install on your host. And these are the various hook points. So basically, there's a lot of them, mostly VM lifecycle ones. There's also a couple like VDSM when the daemon starts, when the daemon stops, and also some network configuration hook that was recently added. And on VM level, you can also do either on the whole VM, create a hook that handles the whole VM, or a specific VM device. So basically, currently only NICs are supported, but there should be support for other device types as well. So let's look at the VM level hook. This hook, what it actually does is remove MAC anti-filtering, MAC anti-spoofing rule. So basically, when you start a VM, usually it will not allow you to spoof the MAC inside the VM, not allow you to use a different MAC. This hook, if you install and use it, it will allow you to use any MAC that you want on any of the devices, on the network devices. So the important parts are, there's a custom parameter that is sent to the hook. There's a parameters map that is sent. We will see where it is filled. And we check if this parameter exists, if it's active. Only then we do the hook logic. So most of the hooks act like that. They don't just act automatically. They only do it if you specify some custom parameter. And then the other two lines is the read XML and the write XML. So we get the XML for the entire VM. We act upon it. We do whatever changes that we want to do. And in the end, we write the XML back. And this is what gets sent to libvirt or to other hooks, because the hooks can be chained up. But you don't have an order of execution. So each hook basically runs solo on the XML. And the custom parameter is specified, in this case, on the virtual machine level. So you have a custom properties tab. And you can just add whatever custom properties you want. In this case, you want MAC spoofing. So you say MAC spoofing, and you say true. You can also say false, and then it will obviously not run the hook. And per device level, you can do basically very similar hook. So it also checks if there's some custom parameter. But the two lines that I read and write the XML, it's just for a specific device. So this is just if you want to affect a specific, let's say, a network interface, you just want to allow on that network interface to do MAC spoofing, then you can do it instead of affecting the whole VM. And to specify it, you also have a place that you specify the custom parameter. So how to write a hook? Basically, you need the hook scripts. Of course, these are the scripts that do the work, like the scripts that we saw, the Python scripts. And you usually include a README that says, what does this hook do, and how do I configure it, and how do I use it, how do I consume it via oVirt. And maybe you need a sudoers file if your hook, like this hook doesn't call any external method, like external command. But if you're calling external command, you need sudoers file to enable it, and just a make file to install the hook. So basically, these all exist in the VDSM source code. You can see there's a VDSM hooks directory, and you can look at the different hooks and see how they do it, and just take inspiration from there. So that's it about hooks. Let's talk a bit about scheduling API. So basically, hooks is just extending one single host, and it's a very flexible mechanism. You can change the entire way the VM is started. What we need to remember, hooks, because of their flexibility, they can also not run, because if they're not installed on the host, then the hook will not run, and it doesn't matter that you specify the custom parameters. So it's kind of like a at your own risk mechanism. And that's affecting the VM lifecycle. Scheduling API, this is how we can change how the engine actually starts the VMs, on which host it selects to start the VM. So basically the need was because users wanted to do some specific scheduling, and there was no specific scheduling done. You couldn't choose like which host would start the VM. There were just a few basic algorithms that didn't take into consideration like user requests, like someone wanted a maximum of 3 VMs per host. He couldn't do that. So the old scheduling mechanism, basically, it just had one distribution algorithm that is based on CPU load only, and it would basically either evenly distribute the VMs by CPU load, so it looked, okay, this host has 10% and this 50, so I will put it on this host to have like 50% CPU, and it has some logic like that. Or power saving, it tried to condense all the VMs on the hosts which are more used by CPU, and to reduce CPU usage on other hosts. And the scheduling itself of the VMs to select which host to use, it was just basic modules that are hard-coded. So the VM needs to have the devices, and it needs to have the host. Sorry, needs to have support for the devices, for the networking, for the storage. Needs to have enough memory available, and so on. And load balancing is a periodical task that was running, and also like trying to balance according to the distribution algorithm. It also didn't have too much extendability, so basically this whole mechanism wasn't like extensible by the user. So the new mechanism actually changes the entire picture. So we have a scheduling policy, which is a policy that you select per cluster level. And on this scheduling policy, you can put filter modules, so filtering for the host that we select. Wait modules that are just if you have a couple of hosts left, that it decides which host is the best. And load balancing module, which decides how to actually do load balancing when you have hosts that are already running the VMs. All external models are developed in Python, so user can just write his own models. And the existing logic, it was also translated to models, just built-in models that you can use. And as I said, we can set the desired policy. You can find more information, just a list of existing policy units that you can, it's like samples that you can look and write your own policy units according to these samples. And there's also a wiki page about it, just explaining you how to write external scheduling modules. So let's look at how it actually works. We have a list of hosts in the beginning, and then we have the filter module running. So each filter module filters out one or more hosts, or maybe no hosts, just passes all hosts next. And when we have more than one host left, then we have the wait module that is running, and just decides to give some scores for the host, and the host with the lowest score wins, and this is the one that gets selected to run the VMs. Let's see how we can write a filter module. Basically, filter module just filters out hosts. It's easy logic. It has a set API that we need to implement. And we don't know, we don't know in each order. Each filter module is kind of atomic. It doesn't know what ran before it. It wouldn't know what runs after it. But we do chain them up. Like there is a set filtering chain. And of course, the existing logic still exists. You can still use it. We'll see later how we can mix the existing and the external modules that a user can write. So let's say we want this filter to filter out hosts that have more than 3 VMs running already. So I know it's kind of hard to read, but I'll just explain what are the different parts. So the first part is class definition in Python. It defines the name of the filtering module. It also sets, like if we have a weight module or load balancing module, this will be the name of all those modules. And each kind of module is just a method that we need to implement with a set API. So in this case, the doFilter method, it accepts the host IDs, just a list of the hosts that it needs to filter out, and the VM ID that we need to run, and the custom arguments map that also can be sent from the engine as we've seen, like custom properties for the filter. And then these properties, we can define some validation on them. So in this case, maximum VM count is a property that is a number. And in the code, we get actually the property from the map, if it exists. If it doesn't, there's some default value. And the actual filtering is, as I said, you need sometimes the Python SDK. So in this case, we create an API, a proxy to the API object. We do a query on the host, and then we do the filtering logic on this host according to, in this case, how much VMs are already running on each host. So we need to get this information and filter upon it. And in the end, we just print the list of the IDs, and this list is what's passed on to the next filter. So basically, filtering module, it's the same for weight module, just some different method that we need to implement, and the same for load balancing module is also a method. So we can have a file with one module, or we can have a file with all the modules implemented, and then there's some just logic that this module does, each module does. And this all goes into an external policy unit. So basically, there's some process running on a library on the engine, and it analyzes the filters, the weights, the balance functions, finds them, creates module representations to use in the engine, and it can be used in the engine, so we'll see how to use it. We have this configuration screen. It's kind of huge, so I zoom in a bit. So we can use for this policy unit, we can decide which filtering models we use. So we have the set ones, which are not marked as external, and some external model that we created, for example, this max VMs module. And we also can decide which weight modules we want to use. So we can use the existing ones, or we can use the external ones that we have. Doesn't necessarily have to be like from the same file. It can be like different file. In this case, even VM distribution is something different. And load balancing also, we can decide which load balancing logic we want in this cluster policy. And this basically is the cluster policy that we apply per cluster. So this cluster can have one cluster policy that decides inside how to do the filtering, how to do the weight, and how to do the load balancing. And as I said, we have the custom properties that we need to specify. In this case, I can set like I want a maximum of 2 VMs. Okay, I don't have to set 3, and this satisfies the user's use case. So Rene, UI plugins.
Thanks a lot, Mike. I will now talk about UI plugins. UI plugins is an infrastructure to extend the oVirt web admin interface. It was introduced in oVirt release 3.2. I will give you a short overview about the UI plugins. If you need further or more detailed information, please check out the oVirt wiki and also have a look at the real-world examples that you get a feeling what can you do with UI plugins or which UI plugins already exist.
To point it.
This is the web admin user interface you are normally working with, and you can extend this interface by creating custom buttons, for example, creating different tabs, and write your code for this object. What do you need to do to create a UI plugin, you first have to create a plugin host page. This is the page that holds the actual JavaScript code, and a plugin descriptor, which is a configuration file and includes some metadata. This is important for the UI plugins, and you can override it on a user level if you want to. Let's have a look at a very, very simple plugin. As you can see, it's basic HTML code and the JavaScript section. One important thing to know about UI plugins is that plugins are executed in an iframe. So you have first of all, you have to access the plugin API from the iframe. You are then calling the API register function to register the plugin event handler, and in this example, we are adding a new main tab. The label of the main tab is foo tab, and it will display the website foo.com in this tab. And with API.ready, we are telling the plugin that the tab can be displayed. As I said before, you can add main tabs and subtabs. This would be a custom main tab, and a subtab appears if you select, for example, a host or a virtual machine or a data center or a cluster. You can set the tab content URL and decide if it should be accessible for all users or just for a specific user group. Next, you can add buttons. These are main buttons where you can decide, should they be only in the toolbar, should they be in the context menu, or should they be in both. You can show dialogues, open dialogues. These dialogues have the same look and feel as oVirt with the show dialog option. You set the dialog content URL and can close it, of course. And you can deal with logged-in users. What are important events? The UI init for initializing it, and the selection change events. For example, you have a plugin or a UI subtab for virtual machines, and if a user selects another virtual machine, you obviously have to change the code or the behavior of your subtab or what you're displaying in it. That's done with the selection change events. You can react on user logins and user logouts, and you can send messages from the plugin using the HTML5 post message API. That was a short overview about the JavaScript code. Let's have a look at the metadata and the default configuration. You have to put it in a JSON file, which is located in user share oVirt engine/UI plugins. It's important that you have a unique name, so each UI plugin needs a unique name and an URL. The URL points to the web page which hosts the JavaScript code. And you can optionally pass in some config options. To summarize, you have to write the plugin descriptor, the plugin host page, and then see your plugin in action. It's quite simple. I will now show you a real-world example that you can have a feeling for what can I do with UI plugins. It's a monitoring UI plugin written by me. It's hosted on GitHub, so check it out. What it does is it displays check results from Isinga or Nagios or other forks in the web admin interface. As you can see here, we have a new subtab named Monitoring Details, and in this example I selected one of the virtual machines, and in this Monitoring Details subtab you see all the host and service checks. Thanks. So we have all the host and service checks plus a few details on this tab. Okay, so next, you can also show your PnP for Nagios performance data with it. In this example, we have the ping times for the ping check of a virtual machine displayed. All this is done using the UI plugin infrastructure for sure, so I created the subtabs. All the code to communicate with Isinga is done in Perl. I use the IDO database of Isinga of Nagios, or if you want to the mklive status API. Then I have the template toolkit, jQuery UI for displaying the results. So the look and feel is nearly like oVirt, and it's all done with jQuery and with CSS. And yeah, I have also included auto tools for configure, make installs, spec files, and as a Linux policy for it. I know it's not that big, sorry, but the plugin descriptor is the same as seen in the example before. We have an URL and a name and config options, and in the config options I have the location of the CGI files. As I used Perl for it, there's the location for the CGI files. For the actual code, with api.add subtab, I'm adding the subtabs for data centers, clusters, hosts, storage domains, and so on. And sending a get variable to the CGI scripts that the scripts are aware of what type of result should be displayed. If you select another data center, another host, it's done with the data center selection change option, for example, which passes the name of the new data center to the CGIs. As we were talking about monitoring, I just want to introduce another project done by us. It's a monitoring plugin for Isinga and Nagios written in Perl, where you can monitor all your data centers, clusters, hosts, virtual machines, and so on. It's written in Perl, as I like Perl, and it uses the REST API Mike introduced before. Yeah, if you have questions, you can ask them now. Please also check out the oVirt wiki for more information. Join the mailing list, or join us on our IRC. Thanks a lot for your attention.
Thank you. Any questions? Okay, thanks, guys.
Thanks.